Welcome to Mathema by RC YouTube channel. This is our 7th class of real number of class 10. In this class, we discuss a theorem that is root 2 is irrational. Okay. In this theorem, we prove that root 2 is irrational. So, suppose how we can prove that? In this, I use a contradictory term. That means we suppose we let down the root 2 is rational number, not a irrational number. Okay. So, suppose and contradict this term, because root 2, if root 2 is not rational number, then it is irrational, because in this real number term there is either rational or irrational. Because in this previous class we discussed what are the real numbers and the different type of real numbers and the properties of real numbers, the division lemma, and also the fundamental theorem of arithmetic. If you could not see the class of this channel, you go to our YouTube channel or playlist of class 10, you get all the classes. Okay. Suppose root 2 is rational. Okay. Suppose root 2 is a rational number. Then we get two integers, suppose s and r are not equal to 0. Okay, are not equal to 0, and we get root 2 equal to s by r. We know that all the rational number can be represented in this fraction form, that means p by q or s by r. Here s by r, s r are integers, where s and r integers, and we write down root over root 2 equal to s by r. Now s and suppose s and r have some common. Suppose s and r have some common other than 1, and they are not co-prime, other than 1. So, they are not co-prime, they have some common term. Okay. Then we simplify this s and r, then we simplify s and r and get a and b, where b not equal to 0. Okay. So, and we take root 2 equal to s by r, and crossing down we get a and b, and we get ab, where b not equal to 0 and ab are co-prime. Co-prime, that means they have ab are co-prime. So, they have no common other than 1. They have 1 is always common, any two numbers, but other than 1 they have no common. So we cross multiply this, that means root 2b equal to a, and then we square this both term, root 2b the whole square equal to a square. Now we get 2b square equal to a square, because root 2 the whole square equal to 2, root 2 and root 2 we get root 2 and root 2 we get 2. So 2b square equal to a square. Here we say that a square is divisible by a square is divisible by a square is divisible by 2, because we say that here 2b square equal to a square. So a square is divisible by 2. Okay, since a square is represent as a 2 into b square, so a square is divisible by 2, and we take suppose a square equal to suppose 2c, where c any integer not equal to 0, because this is not equal to 0. So we also write down here a square equal to 2c. Okay, 2b square equal to 2c, that means b square equal to c. Okay, so a square is divisible by 2. We represent that a square is divisible by 2. Also here we see the theorem, let p be the prime number. If p divides a square, then p divides a, where p is an positive integer. So here we get a square is divisible by 2, so a is also divisible by 2. Okay, on this theorem 1.3, here we get the theorem in your books. Okay, theorem 1.3, we get a is divisible by 2. Okay, a is divisible by 2. So when a is divisible by 2, we also represent a equal to 2c. So in this term we put this 2b square equal to 2c and whole square, and 2b square equal to 4c square, and we get b square equal to 2c square. Here we get b square also divided by 2. B square is also divisible by 2. B square is also divisible by 2. So b is also divisible by 2. So b is also divisible by 2. Then we get here the contradictory, that here we take a and b are co-prime. They have no common term other than 1. So here we choose, then the root 2 is a rational number. This is contradict. That means there is some problem. That means root 2 is irrational number. When we take, if we take root 2 is rational number, then there is some mistake. So root 2 is irrational number. Okay. Then we use this formula for proving this part as a contradictory theorem, and use the theorem here 1.3 theorem. Thank you so much. In this next class, we take another irrational number to prove that this is an irrational number, not a rational number. Thank you, and subscribe our YouTube channel, join our Telegram group. If you like this bottom, then share your friends for this portion, and also join our Telegram group. In this description box you get the link of this Telegram group. Thank you.